All right.
What gives you that power?
Derivatives of trig functions. So if you still have your plate from last year, when we get to doing integrals of trig functions, your plate will be super handy.
I also made that chart.
You can make new plates. I do not have my plate from last year. So, but I do have plates.
So let's all make new plates.
We can.
Do we like do one day after?
No, we're not going to spend an entire day doing one.
What about half a day?
I don't know. I'll think about it.
What about tomorrow?
Because no one's going to be focused tomorrow.
James is still gone.
We all know who's winning.
You give me a reason, and it's a bad reason because the Cats have been real bad this year.
And it's Friday.
They're going to win by at least 30 points.
Right.
I don't like to hear.
Okay.
Okay, so if the Grizz win by at least 3 scores on Saturday, on Monday we do plates.
Okay. So,
Yeah?
no. So f of x equals sine x.
You're not confident that they're going to lose?
F prime of x is equal to cosine x. So if we have a function that's the sine of x.
Why did Miss Lexi let me use the plate last year?
Because Miss Lexi didn't like the plates.
What? I don't know why.
She wanted her students to have all of those places on the plate memorized. I was fine with you guys using the plates, so she and I just had different philosophies.
I almost did have them memorized by the end of the year.
Great,
Yeah, I just do that.
and that's fine. And there's nothing wrong with Miss Lexi Mrs. Lexi wanting people to have them memorized. So let's say f of x is cosine x. Then f prime of x, the derivative of that, is negative sine x.
Wait, if f prime of sine is
And the derivative of cosine is negative sine x.
that's weird.
Okay.
But like, why is that? Just actually.
So to show you why, I would need to go back to the definition of the derivative and go through that proof.
No, thank you.
No, thank you.
Okay.
Yeah, you know what? I'll just take your word for it.
Great. If you do want me to go through the proof with you, I can.
I'm slightly curious, but I'll be curious on my own.
Okay. All right. So let's say we have a function. Guess what the next one is?
Tangent.
Tangent. So f of x is equal to tangent x. The derivative of tangent, this is where it starts getting messed up. The first two are easy. This is where it starts to get complicated, is in parentheses, secant x parentheses squared, or you could write it as secant squared x. This is where it starts to get trippy. Mm-hmm. Okay. Your feet are on stable ground, Kim. That's okay. So now we did sine, cosine, tangent. So let's start by doing the inverse of the sine. Do you guys remember which one is the inverse of the sine? It's
Cosecant. I said
cosecant.
I said cosecant.
Oh, I'm
That's what I
sorry.
said too.
Hey, I'm sorry. I'm sorry. You can kind of hear your voices.
So talk louder.
Okay, yeah, you can kind of hear your voices. Okay, so let's say f of x is cosecant x. Then the derivative of cosecant is going to be negative cosecant x times cotangent x. I know, I'm excited too.
Let me guess, this is all for your favorite thing.
No, this is not my favorite thing. Nope.
Do you have a least favorite thing?
Yeah, oh yeah.
What is this?
What is my least favorite thing? So there are some aspects of three-dimensional calculus that I don't like. I really don't like eigenvectors. I really don't like eigenvectors.
So what is that? Do we do the plate on Wednesday when we're already out?
Possibly.
Have you been thinking about this that whole time?
Okay. So sine x, the inverse of sine is cosine. What's the inverse of cosine? Or the inverse of sine is cosecant. What's the inverse of cosine? secant. So let's say we got f of x is equal to secant x. The derivative of secant is secant x times tangent x. Then we got one more to do. And then we can start using them.
Cotangent.
Yep. So say we got a function that is the tangent of x.
Wait, when cotangent?
Oh, sorry, cotangent. Jeez, Mr. Taft. So cotangent x. Sorry. I'm an imperfect person. So we have a function that's cotangent x. The derivative of that, f prime of x, will be equal to negative. And I'm going to write this two ways. One way would be in parentheses cosecant x quantity squared, or you could write it negative cosecant squared x. Either way.
What is the difference in the way it's written?
They mean the same thing. It's just depending on which way you want to write it. It could show up either way. Okay. So, let's take a look at some examples from your assignment. Because your assignment has you, because we're so far into derivatives and everything, I decided not to make it just you simply finding the derivative. I decided to throw in the chain rule and the product rule as well. For funsies.
Well, that sounds so fun.
What the heck, Mr.
No,
Taft?
that's today.
Boy, I'm excited.
Come on, man.
So you're going to not just find the derivative, but you're going to find the derivative along with using the chain rule and the product rule, because you guys are like masters at this by now. Right?
Am I next?
Sure.
We took a test. You guys all did really well on the derivative.
Not really. I don't think. I need a sandwich.
Okay. So with this first one here, so the first one we're going to use the chain rule because we got something that's inside here. So first we're going to find the derivative of the sine, and we're going to leave what's inside alone. So the derivative of the sine is what?
Cosine.
Cosine. So we're going to do cosine, and then we're going to leave what's inside alone. And I'm going to put parentheses around it even though there weren't parentheses here. I'm just going to do that for me just because it makes things fit easier in my brain space. So this is going to be cosine 2x cubed. I'm going to put parentheses around it. Now the chain rule says that you're going to do derivative and then leave what's inside alone. And then I'm going to multiply it by the derivative of what's inside.
So 6x squared.
Yeah, and so I'm going to multiply it by 6x squared. So I did the derivative, I left the inside alone, and then I multiplied it by the derivative of what's inside. That's it.
Oh, that's easy.
That's our good old friend, the chain rule. Now, question number 2, question number 6, question number 8, question number 9 are just like that. Okay? So all of those use the chain rule.
Oh, that's
Yep, that's me. Annoying.
no, not that. There's just the one problem. And then nothing.
Oh, yeah. Yep, I did that.
And then.
Yep. Okay, so let's take a look at question number 3. So question number 3 uses our good old friend Mr. Product Rule. So the product rule, in case you forgot, is if you have f times g and you need to find the derivative is f prime g plus g prime f. You guys remember that? Cool. So I'm going to say the first thing here is f, the second thing is g. So I need to be able to find out what is f prime equal to and what is g prime equal to. So f prime is 12x cubed, sweet. And now g prime. So it's sine, so cosine, right? 2x cubed goes inside, and then I have to multiply it by 6x squared, right? Because I just did that right up here. Right? Cool. Okay, this isn't too bad then. Okay, so now I'm going to do f prime times g, and I know what f prime is because I just wrote that down because I'm smart like that. So I'm going to do f prime, which is 12x cubed, times g, which is right here, sine, and I'm going to do in parentheses 2x cubed. All right, I'm halfway there, plus g prime, and I'm just going to move that 6x squared to the front just because it makes me understand it better. 6x squared times cosine, parentheses, 2x cubed. So g prime times f, and then f is in parentheses 3x to the fourth plus 5, close parentheses. I can go a little further than this though.
There's no plus sign.
In regular old f there is,
Oh, sorry.
because it's g prime plane f.
Yeah.
I can go a little further than this because I'm an intrepid young calculus student.
No.
No.
I can distribute the 6x squared cosine 2x cubed to both things inside the parentheses there.
Oh my goodness.
No, I can. It's not too much to ask.
You can.
Oh, it's not too much to ask. So 6 times 3 is 18. X squared times x to the fourth is x to the sixth cosine 2x cubed, right, plus 30 x squared, and then over here all this other stuff is just the same, 12x cubed sine parentheses 2x cubed, and then plus. Now I'm done.
Wait, where'd you get the plus 30?
Shouldn't there be a cosine on the other 30?
Oh, you're absolutely right. I made a mistake. Thank you. This should be 30 x squared cosine parentheses 2x cubed. Thank you. Hey, you're right. You're right.
Wait, you are not confused how you watch. She got me a paper bucket. She got everyone a paper bucket.
Okay, so how I distributed that. Let's talk about it.
Thank you.
So, number times number, make 18. X squared times x to the fourth, make x to the sixth. And then the cosine 2x cubed just tags along. And then number
So
times
wait,
number.
so you just attach that after you distribute the symbol?
Yep.
So it's somebody.
Number times number, 30. X squared times no x squared. The x squared tags along too. And then the cosine 2x cubed tags along.
Okay.
Okay.
So I help you rewrite tangent and have cotangent.
Oh,
Then
you're
don't get
gonna get all like that with me?
No. I'm just
Good lord.
You put that window real quick.
Mhm.
That should be really hot.
These grapes are sour. Mmm.
Oh, it's the back.
why Claire's so bad.
You look kind of dead.
I was trying to get over to somewhere in your area to see if I can see if that'd be great.
Oh, this is red. Oh, that's
Why are those windows so blinding?
Why are those windows so what? Blinding.
Because of the sun.
Do I need to explain line?
Actually,
Well, no, like, just like-
just let him leave him hang. Let him hang on this one. Don't answer.
No,
They're telling them to give them a quick.
There's certain classrooms, like the windows just suck the way they're placed.
Do I? Okay. I'm not meaning to sound as sarcastic as I'm sure I'm coming off. Do I need to explain placement in physical space to you?
Sure.
Here, take some cancer about that. That's your reward.
It just has to do with like, so the way that the sun goes, this is 90 degrees to it.
Where's that?
And so because it's 90 degrees, it's more direct. Whereas like if you're in Mr. Thackeray's room, you get an oblique angle. And if it's an oblique angle, it's also why I have these desks tilted. If it's tilted, your glare isn't as bad. Whereas if you move these so that they're straight forward with the board, the glare is going to be worse. No, the way that you have it now makes your glare better. Makes the glare not as bad.
Like, this is the reason why I said, because like Miss Bedford's, if you go in there first thing in the morning, you're gonna get blinded.
No, I know. Have you ever tried to take a picture of like an aquarium? Like at like SeaWorld or anything?
Yep.
So if you try to do that, if you stand directly at the aquarium, your flash is going to make it so you can't see anything. You have to stand at an angle to the aquarium if you're going to take a picture of it. You what? I don't know. But if you stand at an angle to it, then you will be able to see it better because the oblique angle is going to make the reflection of the light not as bad.
It'll go.
Right. Whereas if you're directly at it, it's not going to. It's going to be way worse.
Gotcha.
Okay.
That makes sense.
Great. So,
Sorry for wasting time.
no, it's not. It's not a waste of time. If it made you understand it better, it's not a waste of time. Okay. So, you guys now on the backside. On the backside. 11, 12, 13, and 14 are what we were doing yesterday. So you find the antiderivative, and then evaluate the antiderivative at the number on top, the number on bottom, and then do this minus that. Okay? And then that's going to be the area under the curve. There's only one where you have to do the approximation. So you're going to do 4 left endpoint, 4 right endpoint, average them, and then use your calculator. But there's only one of these now. So I'm cutting down the number that are on your assignments. Okay? Can we what? Okay.
Started cutting down the assignment.
Well, I mean, you can always choose to not do it.
That time of year where it gets like darker earlier outside, and it's just way harder to do the homework when it's dark out.
Mm.
Yeah, I understand, because you just want to
See,
sleep.
like, your body wants to go to sleep. Like, you ever been jet lagged really bad?
Yeah.